Welcome back to Realistic Progression 1, or Realism Overhaul, whichever one you want to call it is absolutely fine by me. In here in our research and development department, as you may have noticed as I was flying various sounding rocket missions, some of this technology we've chosen to sort of research to get some points has now actually been researched so we can buy upgrades. So I've just gone ahead and bought this Aerojet upgrade. It's a little solid rocket booster motor, just like the tiny one that we started with. It's the one that just lifts everything off the launch pad really quickly. This is an upgraded version, essentially. So that, and it can't be shut down once it's started. So yeah, you better hope that that is, there we go. So that is, its part is still the same thing, the Tiny Tim, same as the original one. But I think it's going to be better. Let's have a look. Thrust is 46 kilonewtons. In vacuum, but at sea level it's 39 kilonewtons. Okay, and let's see. Mass is 0.2. So if we look at the original node you start with, have we got the kick motor in here? Probably is somewhere. Find it is actually the harder part though. I can't search in this interface unfortunately, but we can search once we get to the VAB, so I'll compare with them once we get there. Anyway, the reason I'm in here is for, not for you, but for this post-war rocketry testing. We're going to want to upgrade our original Aerobee so that it's more capable, and all the other variants that we've created, that, well, there's only 2 variants I think so far. So we can do that. We can get this node. You'll see it says post-war rocketry testing. It's researched. And normally you would buy these. Okay, so the XLR-1. We don't want to buy that just yet. We could buy it, but it's more for the supersonic X1 aeroplane. I say aeroplane. It's a little bit like a rocket with stubby wings. But yeah, that's for the X1. However, there's this bunch of stuff that looks it doesn't have a value on them. However, if you hover over them, at the moment in the current test version, there's this problem. It says purchase entry cost 188,750. Thankfully, that's not what you have to pay for those. So when you get something like this, if you are playing in a similar version to me before release, because it's not out fully yet, ignore those. Ignore anything in here that's an upgrade on technology to an existing engine. Instead, what we're going to do is leave here and then go into the VAB. In the VAB, we're going to be able to upgrade the engine directly from the placed engine in the world. So you'll be able to right-click it and choose a different engine. So let's, what have we got in here? Have we got the RP1? I think we do, yes. So RP1, just to take a look at this, in the atmosphere it's around 1846, okay, 1846, that should do. That's 50 seconds, I'm not overburning this particular one. This is the RP1, the very first one we started with. And to upgrade this, let's just retract that for a second, just to keep it simple. And right click on the RP, and then we can go to engine. And then purchase the XASR-1 for 1,000 funds. Okay, so if you look at the left-hand side of that, it says, okay, its rated burn time is 1 minute and 5 instead of 50 seconds. So if we purchase this, we'll have spent 1,000 funds, but you'll see now that the time that this will last with that existing fuel tank is 18 seconds. So it's now only 1,000 instead of 1846. But that's understandable. You know, we need a different rocket. Essentially, it's going to need more fuel, and we need to make it last. We're going to need to last longer, so we need more fuel. So let's construct something a little bit bigger that's got the XASR-1 in mind. And indeed, what we can probably do, in fact, I won't do it on this, but I'll do it on the next one, is swap this out. So the Tiny Tim booster, let's take a look at these engines just while we place that. So the Tiny Tim is 0.3 tons or 0.33 tons. Whoops. And that is 220 kilonewtons. And this one is 46 kilonewtons. So it's nowhere near as powerful as the other one. Interesting. So let's take a look. Solid fuel, you have 15 litres. What do you have? 57 litres. Okay, so it's a smaller version of the same thing. And maybe we can use that as a kick motor in space. That may be a possibility. And if you don't know what a kick motor is, essentially it's a motor that you will fire and it will use up all of its fuel. Let's say you lofted a ship or a rocket up above the atmosphere and pointed it roughly sideways, prograde direction, if you want the technical term, and you hit your kick motor. If you're pointing in the right direction, it's going to expend all of its delta V, and because they're very good at that, it applies all, almost an instant. So if you calculate things, you can get things into a certain orbit using kick motors of the solid variety. I'm going to leave them alone for now. Let's go back to sounding rockets and let's actually look at the upgrade for this Aerobee. Okay, so here I've started it, the Aerobee 3. And you'll notice it's 1:05, just like it said we would consume. But if you look at the atmospheric delta V, this on its own, without anything else, is 2,900. That's almost as good, in fact it may even be better than that first two-stage rocket that we built last episode. So this just by itself is really good. We can of course add the usual bits and pieces to it, so we can carry on with this, and we can probably use the same fins. Either 3 or 4, doesn't matter, but it just makes it easier if you're going to have 4, unless you're going to want to spin stabilize this thing. So in that case, you just want to go back to 2. And let me just make sure I can snap this into the right area. There we go. And we'll snap them again, just here. And Shift C to go back down to 1 degree. Change to rotate. And then we should be able to just rotate just a little bit. There we go. Just a tiny, tiny amount, nothing more. That should do just fine. Okay, now we could launch that. But given that it's a sounding rocket anyway, we may as well attach the rest of it. So we do want the separator. And because we're using this particular model, rather than the engine that looks a lot like this, this separator just looks nicer for that kind of thing. Normally, otherwise, I would use, and I probably will switch. In fact, let's switch now. Yeah. So let's put in the Aerobee rocket engine. Just because these tend to be quite nicer, they're shaped like a typical rocket engine. It's not got all the attachments on it like later engines. It's quite small and quite simple in terms of model, but we can switch across to that. You'll see it's exactly the same figures. There's not much difference. In future, we will build in the boat tails, and those are the things that come down, so you can barely see the rocket engines at the bottom. But so simple a rocket with a sounding rocket, we're not going to do that kind of thing. So we can then build decoupler. We'll adjust the sizing in a minute. And then let's just take a look at these. So just to verify this does 218 meters per second delta V for 4 seconds. This one does 153 for 0.07 seconds. Okay, I thought this was a downgrade. That's definitely not a downgrade. Sea level thrust is 5. What is this one? 22. Okay, so this will apply its thrust in a much shorter space of time. So we don't have really much in the way of lag time for that. So I think I'll leave the original on there. Why not? And no, let's give the new one a try. Why not? Even though it's nowhere near as fast to take off, I just want to see what it's like. It's probably more efficient to use the other one, but we won't worry about that too much. And again, we'll just get the structure, the aerodynamics, and we really don't have to worry about this one in terms of tilt or anything along those lines. And finally, just a structural connector, the launch clamp. And of course, as normal, check your staging before you go any further. In fact, are you connected? There you are. There you're connected. So because everything's going to fire simultaneously, we're going to simulate this in a second, and we'll probably need to tool everything once we actually do that. So let's release the launch clamps at the same time as we fire this one. And it's going to take 4 seconds. So we really can get away with Interesting. Technically, I can fire the second engine and then release. And we're going to bring that in. What it may be is, it may just be so hard to do that because if I get into lag whatsoever, I've only got 4 seconds. So we may want to go back to the other booster. But for the moment, let's just bring that down. And you'll notice the cost went way down. That's because of the size of this. So I guess you could just tweak the cost down a little bit more. I think that's a little bit cheaty, don't you? So we should have at least a certain size of the decoupler. Okay. So shall we simulate this? Let's just save it, and let's just see before I do that what tooling it says that you need or what we can do. So we can tool the decoupler. That's procedural. We can tool the nose cone up here, and we can tool the tank as well. So all 3 of those. Before I actually do that, I'm going to simulate. I hope the simulate doesn't actually... In fact, let's just see. Simulation cost 364.3 estimated per minute. So that's going to cost me 400 for a minute. Let me just tool one thing and let's just see if that actually brings that cost down, shall we? So let's just tool this item. Okay. And then see if that cost has gone down. No. So we don't need to worry about that for simulation. Let's start it up. Oh, experimental parts were not available at the moment. Yes, I built this in the test area, so I need to go and just save this for a second. This is simulation active. It's really not active. Let's leave. And I do need to go and buy that ion experiment, which is over in the R&D. I think it's the first experiment available to us, so we may as well go and see what we can do. It's going to be down here, in here, I think. Yep, it's going to be 5,000 cost. Lots, but because it's science, more science gets us more science points, gets us more upgrade points, gets us faster building. And why not, we'll buy the basic battery as well. Again, because these don't have an entry cost, we should be able to buy them from the VAB. If we can't, we can come back here. They don't actually have any cost to them, at least in this current test version. So I'm going to leave them alone for now, and I'll do a bit of investigation later. All right, back into the VAB, and we'll start up the simulation. And one quick correction, I didn't have this tank on the high pressure mode. Do make sure that happens, because I swapped the engine over, if you remember. So make sure your highly pressurized is true, otherwise it won't be able to pass fuel down to the tank, to the engine. Okay, so we've got that as is. If you right click on the engine, it says propellant very stable, which is exactly what we want. We're going to save that, and then we're going to start the simulation. Okay, so we're here on the launch pad, and whether we use this booster on or the other one will depend on how it goes. It's going to give me 4 seconds when I press space, at which point a second and a half before it finishes, we want to press space again, and then as soon as that kicks in and the first stage stops working, then we hit space again, and we're going to detach this top phase stage. Now, hopefully that will be long enough for it to start spinning and stabilize, because we don't, if I press T, there is no SAS. Okay, so this is very much back to the start, but with an upgraded engine. So what can we do with just a single stage, or with a kick stage, without resorting to a larger rocket? So shall we get started? Yeah, let's give it a go. So stage 1, or stage 2 I should say, there goes the engine, and there we detach. So we are spinning nicely, and we don't really have to do anything else at this point. It's going to continue spinning. This is probably the least spin we can actually attach, and we are now, if we have a look at the delta V stats here, we're going up, our sea level thrust is going up, and our atmospheric delta V is going down, as you might expect. So now we just have to see how far we can get with this rocket. But now we're down to stage 0. Okay, so it's not going to take too much longer to actually go out of fuel. What have we got left? for the records. I suspect we'll be able to pass a few of these. I've done some that will get us to 800 kilometers. The previous rocket, I couldn't quite get to 900, the one from the last episode. It kept on topping out at 850 or something silly, so we're going to have to build a new one. But each of these now, 900 kilometers and 1,000, are going to be quite a lot of money. You know, 12k, 14k, etc. And that's, you know, a huge amount when considered this rocket is like 500 or so. So if we then just rotate for a second, let's see how well this rocket does. Okay, this is at 221, and we're going to get some science. The science isn't terribly huge, but it does have a science experiment on board, so it can reach 220 by itself. And let's just have a look. I didn't put any fuel in here, I don't think. I just put the experiment in the nose cone. So we have everything we need. So this top phase, 220 with the kick motor. We can do better. Okay, so what if we took the RP2, which we made last episode, and we created a sub-assembly out of this bottom section. So if I grab this, and I go down to sub-assemblies, and drop it here at the bottom, we can create a sub-assembly. So let's say we call this the A4 first stage. Okay, and let's just open, don't save. Open the RB, what was it? What did I call it? Was it the 3? I think it was the 3. Yep, that's exactly what I called it. And then let's just get rid of all of that part. I'm not sure whether I'll need to get rid of the decoupler. Normally, we need a separate decoupler, so I need to keep that in place. So let's move this up, shall we? And let's go up here a little bit. And in sub-assemblies, we can grab that entire section and put it here. Everything's still within bounds. And now, as you can see, we've got a 2-stage rocket again. But now we've got the first stage, which is 2,600 meters per second, and the second stage, which is another 2,300. Now, if this was in the regular Kerbal Space Program, that would put us not just into orbit, but yeah, well into a larger orbit. So we need about 4K, I think, in default Kerbal. So an extra 1,000 meters per second, probably out to a moon. So we've got to configure this a little bit. Let's first grab the payload bays. Or do we want the conic or do we want the egg-shaped? Let's go for conic. And put 2 of them in. Okay, again, just covering the sort of fins. We're not going to do... In fact, we may not even need to cover the fins, to be honest. We may need to just be able to remove the fins because we have a much more stable rocket that may have some control in it. But I'll leave them on for now, and we'll come back to that in a little bit. Okay, so again, let's just check the staging and make sure everything's okay. So that's definitely not going to go there. Let's just move them up to the top for a second. So we're going to fire the rocket, release the clamps, and then at some point we're going to want to add a stage. Remove these. Then we're going to fire this rocket, and then we can detach both of those at the same time. Makes sense? So I'm going to save this as the RB3B for the moment. And let's just check a few fuels. So show the user interface. That's got fuel because it's saved as the subassembly. So we shouldn't need to do anything. Propellant is very stable. Let's just take those off for a second. I know that's going to need, but I just want to double... give me control back. Just want to double check this one as well. Yeah, that is also very stable. So let's put them back in. And are they in the right place? Yes, they are. Good. So I think that's pretty much ready. Let's just bring that down so it's close to the ground. Ironically, well, not ironically, but you can actually get a boost. If you wanted to really min-max this thing, we could just put it right the way at the top of the hangar. But consider having some launch clamps, 100 meters above the ground. It seems to be a bit disingenuous, sort of cheaty kind of thing. So let's see what we can do with this. And let's just quickly check the tooling again. Okay, so we'll make large savings on the tank, which is the 2.6 meter tank, so it's probably this. No, actually it's this one. Because everything else has been tooled because it's part of our previous rocket. We'll reuse that as much as possible. And let's actually see what we can spend on simulation. Again, only about 500, even though the rocket will cost 1200. So we can start that simulation, and let's see how it goes. Okay, we're on the launch pad again. Now, of course, we don't have that kick motor stage, so we can do some, hopefully, regular rocket-like ascent rather than just the first 4 seconds. So let's give it a go. Can we enable SAS? We can. Let's start it and let's see if we have the avionics. Engine start and release. Insufficient avionics, so we're going to have that until we drop below a certain amount in terms of tonnage. We need to drop 2.8 tons before we get the control back. But as you can see, we're fairly stable on the liftoff, so I don't have to worry too much about it just yet. And we can correct once that finishes. So do I have control yet? Should get it back fairly soon. There we go. We've got control. We've got both roll and pitch and yaw, but I'm not going to change those. I just want to see how far up we can get. Maybe, I suppose we can just adjust it sideways a little bit. Okay, so I've got 34 seconds of fuel left. Remember, with this particular rocket, I have to remove SAS, which we can do. That should stabilize with the airflow. It's going to go through a heating zone at this point in the atmosphere, pretty dense, sort of max Q kind of area. And now, well, we're going to probably start spinning up a little bit. And I'm going to release the fairing. Okay, and we got 3 seconds. I'm going to start the engine. And release. Now, we're back to the top stage again. And of course we've got science, but of course this is still in a simulation, but I want to simulate just exactly what we're going to be doing in a normal rocket. And that's done. We may well be able to get more. In fact, I can't get any from transmitting this. I didn't spot that. So we can take this off because this is definitely not going to be recovered. So the only way to get science back from that one is by recovering it. And that just isn't coming back. There is no chance it's coming back intact anyway. We don't have any parachutes and we don't have any heat shields yet. So we are stuck sending stuff out just yet, until some more stuff is researched. However, what we may get is more science of, the temperature, the pressure, the what's the other thing that you can get that's built in? Telemetry. Yeah. So we're almost out of fuel, which means we'll get to see exactly how far this thing will go. It's starting to spin off axis now, starting to wobble a little bit. So how far will this go? Okay, 1.2 million meters, which will be enough to get us probably three different ascent records in terms of altitude. And will it get us speed? I don't think it's going to get us speed because we haven't passed 4,000. That may well have to wait for like lunar returns because, or actually no, that could be orbital. Yeah, that will be orbital. So when we go suborbital, we're going to go this way a lot more, sideways. And as that happens, getting to orbit will pass through this and quite a few others, I think. I need to look up the exact orbital speed, but if I haven't already put something in the description, I'm sure someone in the comments will say exactly what the orbital speed is for Earth. So this should get us some sign-in rocket missions. Let's see what we can do. And while we're back here, let's take a look at mission control. And it's going to give us various things to do. Reach a suborbital trajectory and return uncrewed. Well, we can't really return. We don't have any heat shields. But of course, you're going to get quite a bit of money when you decide to do that. First artificial satellite. That one is going to be an absolutely huge amount of money. The thing about that is that orbit is a lot harder than in regular Kerbal Space Program. So yes, you will get given 2 years in terms of duration to do it. You'll get given a huge advance, but at the same time, you're going to need the technology and the research to do it. So what I prefer to do is try and get science, try and get upgrade points, which will let us build rockets faster, to fulfill stuff, to get lots of money, and then we can worry about this later. Orbit is relatively hard. It's not hard at all in Kerbal Space Program. Point up a bit, go a bit sideways, and you're done. Not so much on Earth. Although it's technically true, but there's 3 ways of getting to orbit, and I'll go through those more in depth with you at a later point. It's basically how you fly the mission. The one is sort of very much like Kerbal. The 2 others aren't, though, and they're far more realistic ways to fly rockets. And that's going to be something that I need to do in later episodes as well. I'll probably have to fly this more either with MechJeb or with KOS, because you can't really design something really efficiently in terms of orbital ascent and fly it manually. The 2 don't go well together, and you on some of the, at least on some of the early craft, you're very bleeding edge as far as trying to get to orbit. You'll either get to orbit or you come back down. The 2 things are the 2 possible outcomes. So what we can do, however, is choose more sending rocket missions for the time being, but they will continue to get harder. So this one will get us 5,000, and it is altitude over 1 million meters. We know we can take that. If we do, we'll lose the other sounding rocket ones, however, so you can look at those, and they're all similar, but the difficult one, this one is pretty much the same as this. Oh, sorry, hang on. No. Yeah, it's 1,000 meters. That's only 100 kilometers, but you need 1,000 units of payload. I don't know how heavy that is. It's a very, very similar reward, but I think we can just go for this one. We know we can hit this one. We've just simulated it, so we'll take that. I don't think there's anything else we can take just yet. We can go into X-planes. That isn't a great reward, and it needs to be manned, and you have to maintain altitude. And yes, so we have to design a plane for that one. Maybe we'll do that in a separate episode with horrendous problems for whoever's on board. But what else can we do? For solar powered satellite, not a chance. And break the sound barrier, crewed, that will be tied in with X-planes. So for now, we can go back and we can launch a satellite. And because this is our current Premier vehicle, we can tool the rest of the parts that we haven't yet to lower its ongoing cost for each rocket that we make. Because some of these initial ones, the XASR upgrade, I'm not sure if that's actually, if we can actually research it to actually improve the failure rate or make it fail less. Let's just quickly grab that and see if we can research and develop that. No. Okay. Fine. If we can't do that, that is a good thing, because it means that we shouldn't have the problem. Let's make sure those are in the right place. Yep. Okay, so we've got that going. Let's save this for a second and look at the tooling. So I want to tool the nose cone, which is this. Okay. 221 funds. And we want to tool this tank as well. Okay, and it's down to 1,000. What we can also do is just pop that at the top. Get rid of this. We don't need it. Down to 782. I've left the other experiments on. I don't think they cost all that much more. 1. So the only cost is mass, and the mass, as you can see, is tiny as well. So it's only 1 kilogram each for each of those. So you could really push the envelope by removing them, but we shouldn't need to. The other thing we're going to design and do next episode is biological sample capsule and early film camera. We'll see if we can get both of those going. Again, we may have to worry about whether we can retrieve them. So one of the ways to try and do that is to try and just use the early film camera's casing as the heat shield, and we'll see if that actually works or not. There's a biological sample capsule as well, and if you look at the sizes of them, yes, they're too big for this, definitely in the case of this, but they are within range of our A4. However, we probably need to have a different kind of second stage going. Alright, so I'm going to build this and we'll head out to the launch pad. And just before going to the launch pad, I just wanted to show you the build list so you'd see how long it's currently taking these to be built. So we have 2 of them, and they're taking 36 days, 15 hours each. So that is much improved over what they might cost if we didn't have the upgrade points. We've got 14 upgrade points so far, and there is some spent in R&D, but most of it's in the VAB because we want to build these faster. Okay, onto the launch pad. And now we get to do this for real, which is where Test Flight usually comes in and decides to tell us that engines fail. So it's always worthwhile at least building some duplicates as we get going. So let's take off, and hopefully we won't get a failure, not anywhere near the launch pad anyway. I think Elon Musk was quoted recently on the SpaceX rocket saying that it was SpaceX Falcon Heavy saying, you know, it's 50-50 whether it'll get off the launch pad, but it would be really good if it didn't explode on the pad because that would be the expensive part. And of course it didn't explode on the pad, and it was very successful. They only landed 2 out of 3 stages, but still there's still 2 out of 3 better than anyone else has managed to do. And yes, I suppose I should talk briefly about that payload. Of course, they launched the payload of a car. As good PR stunt, but at the same time it was just a cool thing to do, and I need to keep an eye on my timer. It was a cool thing to do, and of course that is one way of testing a rocket. You need a test payload, and the test payload generally means you know, it's sort of maximum capacity or capacity that you want to carry. And in just a second, I do need to actually watch this now because we're about to hit 15 seconds, so I'm going to start turning us. Yeah. Okay, paused for a second, but that's fine. I'm going to get rid of the fairings, start the engine, and release. Okay, so we are going up. Now test flight could take us or give us a bit of a problem, but for the moment we can just watch that go up. So yes, the car was a test payload. Normally it's a block of concrete or some lead or some water, whatever you actually want to do. And that's how you sort of design rockets, at least in Realism Overhaul. What you want to do is put, we're doing designing rockets at the moment, but on larger rockets, you'll put a payload, just fill a tank up with lead or something, a ballast, and you will build your rocket to carry that into orbit or wherever you want to go with it. And of course, that will let you define just how much you can carry on that rocket. And then from that point onwards, you can choose to fill it with whatever you like, as long as it's below that amount in kilograms. So this is a little bit of a glitch with Realism Overhaul at the moment. The atmosphere disappears, but it'll reappear once we get into space proper. Not sure what that is just yet, but hopefully that'll be fixed in the final version. You should see it shortly. There we go, we're about to run out of fuel. And we have. And we're starting to process around. There you see that there's the proper atmosphere. Let's see how beautiful that looks. We've got Scatterer going, we've got RSS visual enhancements going, and Eve going. They're all kind of visual mods, as you can see. You know, the cloud systems and all kinds of stuff like that. So it's a beautiful game once you have all the visual mods going. And now we're going to go through quite a few different records, hopefully. So let's just watch this one. If I just speed up time for a second, and we should head up. There we go. So we've passed standard rocket altitude 1,000 kilometers. We passed the 900 kilometers, uncrewed altitude record of 1,000 kilometers. And what's our funds like? Okay, 136,633. I think I started this with 115-ish. So we've got 20,000 extra credits. And that's quite a bit at this early stage of the game. Now, are we going to go up above 1,200? Ooh, we are. So we should get another one. So let's see what that next record is. So 136 at the moment. And let's go up to 1,200. And did we get another one? Oh, we're up to 2,000 now. Oh, so the next record is 2,000. That's actually going to be that's going to be a harder one to actually hit. So we should just be able to do missions from now on. Okay, so I'll see you back at the base, and of course we can always get rid of the rockets. Just by hitting range safety. And now, of course, these start to get harder, but we can take another altitude record. I'm not going to do this on camera. It's the same thing. Get above 1200, and we know we've just done that. So that's another one we can take. We're going to get an advance, of course, but we can keep on getting the funds, and those funds are going to be necessary. Because one of the first things we're going to want to spend on, it's dark, unfortunately, but over here on the launch pad, is to actually upgrade this launch pad. It's going to cost us 75,000. But of course, that isn't instant as well. That will take time to actually upgrade. So we are going to want to spend on that fairly soon. And I may even do it next episode. A couple more things. We've got the technology we're going to research now. And we're going to be doing more sand and rocket missions, but probably not on camera. Next time you come back, we'll probably look at the next upgrade that we need to do, which is probably a new vehicle, to be honest. We'll design something new in the VAB. So I hope you enjoyed this episode. We've gone through and upgraded our initial designs with a tech upgrade, and we're now much more capable at sending rockets. We can send them well out of the atmosphere. Next challenge is really suborbital and survive. That's going to take heat shields, or at least something to act as a heat shield when coming back down once we have suborbital. And then, of course, we have to get to a satellite. So I hope you'll join me in the next episodes for heading towards those goals. They are much harder than regular Kerbal Space Program, but I'm sure many of you have suggestions. So if you want to help each other out, if you're familiar with Realism Overhaul, feel free to put them in the comments below about different designs and stuff like that. Give me a thumbs up if you like this episode. Feel free to subscribe and share. And of course, as always, thanks for watching.